Hello everyone, today we want to present about Scalar and Vector in Engineering. My group member is Razila binti Jaafar, Sarah Nuralinania binti Abdul Hadi, Muhammad Afiq Danish bin Muhammad Azni, and Shalini anak perempuan Martura Biran.
A quantity that has magnitude but no particular direction is described scalar. A quantity that has magnitude and acts in a particular direction is described as vector. Scalar quantity only have magnitude. For example, 11 meter and 15 meter per second are both scalar quantities. Vector quantities have both magnitude and direction. For example, 11 meter east and 15 meter per second at 30 degree to the horizontal are both vector quantities. Why it is important to study vector and scalar? Because vector and scalars are important in many fields of maths and science. Vector can be defined in two-dimensional or three-dimensional space. Vector graphics are sometimes used in computers because they can be scaled to larger size without losing any image quality.
Hello, my name is Nurazila binti Jaafar. I present about how to use vector and scalar in solving engineering problem. Vectors are used in engineering mechanics to represent quantities that have both a magnitude and a direction. Many engineering quantities such as forces, displacement, velocities, and accelerations will need to be represented as vectors for analysis. Vector quantities contrast with scalar values such as mass, area, or speed, which have a magnitude but no direction. When dealing with vectors in equations, engineers commonly denote something as a vector by putting an arrow over the variable. Variables without an arrow over top of them represent a scalar quantity or simply the magnitude of that vector quantity. In contrast with scalar quantities, we cannot add, subtract, multiply or divide them by simply adding, subtracting, multiplying or dividing the magnitudes. The directions will also play a critical role in solving equations that contain vector quantities. To represent a vector quantity, we will generally have two options. These two options are magnitude and direction form, where the magnitude is given as a single quantity and the direction is given via an angle or combination of angles. And two, component form, where the magnitude and directions are given through component magnitudes in each coordinate direction.
Assalamualaikum dan salam sejahtera. Nama saya Muhammad Afiq Danish bin Muhammad Azni, nombor pendaftaran 01GGU21F2008. Hari ini saya akan membentangkan tentang cara pengiraan skala dan vektor. Situasi pertama merupakan gambar rajah kren dan seorang pekerja. Jarak daripada ketinggi kren ni ialah 14 meter dan jarak pekerja kren ini daripada tanah ke tempat duduknya ialah 10 meter. Jarak daripada tempat dia ke kawasan kren ini ialah 6 meter. Cara pengiraannya ialah Pak CY sama dengan 10 meter kerana kita kira yang ini saja, bukan daripada atas kren hingga ke bawah kren. Pak CS ni ialah 6 meter kerana ialah jarak daripada pekerja kren ke kren tersebut. Magnitude sama dengan 10 kuasa 2 campur 6 kuasa 2 sama dengan 136. Punca kuasa 2 sama dengan 11.66 meter. Finding magnitude. Tan negatif 1 Y per X sama dengan tan negatif 1 6 per 10 sama dengan tan negatif 1 0.6 sama dengan jawapan akhirnya ialah 30.96. Contoh kedua ni ialah gambar rajahan jabatan. Kita nak mencari bahagian sini. Pak CEX mewakili B yang berjarak 55 meter. Pak CY yang mewakili A berjarak calculating method yang kita boleh gunakan ialah C square sama dengan A square tambah B square. Cara pengiraan ialah C sama dengan 16 kuasa 2 tambah 55 kuasa 2. Yang lupa punca kuasa 2 sama dengan 3281 punca kuasa 2. Jawapan akhirnya ialah 57.28. Sekian, terima kasih.
The conclusion, vector is very important in our daily life and in an engineering. So, we know that vector are used in engineering mechanics to represent quantities that have both magnitude and direction. Many engineering quantities such as force, displacement, velocities and acceleration we need to be represented as vector for analysis.